Right, topic 2 is about descriptive statistics. We have partly done descriptive statistics in second half of last topic, where we have tables, we have graphs. So this is another further numerical measures that you would like to find out from descriptive statistics. There are 3 sections in this topic. The first section is called the mean, median, mode. The second section, we will go through range, interquartile range, variance, and standard deviation. Don't worry if you are overwhelmed with all these words. The third one is we're going to combine the first and the second and come up with a rule. These two are familiar for you. Parameter are it is a number you calculated from the whole population. Okay, so if the population is still this population, it won't change. So for example, the average of the population, if the population have 1,000 people, so the average will not change unless you change the population. There will be one more added in, or some people left the population. Yeah, so otherwise, as long as the population does not change, the value of the parameter will not change. Okay, now what is statistics? We have a population, we take out some, then we call that statistics. We call that sample. So when we take out this sample, we don't take all. Maybe there are 3,000 here or 30,000 here. We only take out 30. So when we calculate the number, the average from here, we call that a statistic. So it's a measure computed from a sample that has been selected from a population. This value, this is only 30, not 30,000. So if I take the first 30, I take another 30, someone take another 30, all these 30 will give a different average, or maybe quite close to each other, but not exactly identical. So the value of the statistic will depend on which sample is selected. So let's look at the very first part of this topic, measures of center and location. Center, take note of the word center. So when you gotten a set of data, a set of numbers, what's the number, or what's the interest of you? The first thing you probably want to know, what's the average of these numbers? Yeah, so the average gives you a center, the sense of center. That is called the measurement of center. Right. So in statistics, there are 3 ways you can actually measure the center. You can measure the center with mean, you can measure the center with median or mode. Right, we will go through one by one. So again, there will be some technical terms that you need to remember, right? So don't worry, slowly you will get them all. Quartiles are under location. Okay, so let's look at what is mean first. Okay, I'm going to do this again. You have a big population, you take out something from there. This is called a sample. Okay, so when you are doing this calculation, you usually start with a sample. Okay, you have 30 numbers, you try to find out the average. The average is called mean in statistics. Okay, it's just an average. In simple word, it's just an average. You know how to calculate average from many years ago, right? So this is how you calculate average. And just take note, from this topic onwards, you to get used to some of the symbols used. Yeah, symbols used in statistics. You know what is N already? What is N? N is the sample size. Is how many data values you have. In your sample here, how many values you have? We have 30, so the N will be 30, for example. And what is this thing? This is a symbol to represent the average of a sample. Okay, we call that X bar. Is read as X bar. Okay, it's read as X bar. The bar is the line on top of this X. It represents sample mean. This symbol will be the same throughout all statistics books. Okay, right. And what is this X? This X means every single data point, right? And this sign means summation. You're going to sum up all the you're going to sum up all the data points. Let me show you this one easier. So you have this data. How many you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the n will be 10. How do you calculate the average for these 10 numbers? You basically add them, right? Add. So in short, we don't need to write this. Yeah, we don't really need to write this now. This is how you write last time. So you just cancel off. You only need to write this. You sum up all the x's. So all the x's will be the data point. So this will be the sum, the sum x1, this is x2, this is x3. So you just keep on adding all the x's together and you get 30 from your calculator. So you just directly go from here to there. You don't need to go through the one at the center, right? Then you say, okay, the average is 3. Clear? Right. So that's how you get this. Now, since you have circles, one big, one small, the small one is a sample, then how about the big one? Right, so the X bar is called statistics because it comes from the sample. So for those calculation, something you calculate from a population, you call that parameter, right? So the parameter is not called X bar. It has another name, and we call that mu. Okay, mu. How do you read this? Mu. It is a Greek letter. So whenever you see any Greek letter in a formula, that formula belongs to population. And also, if you notice that the n here is a small letter n. Okay, the n here is small letter n, but the n on the other side is a capital letter. So if you see any capital letter for a formula, that formula also belongs to population. Yeah, except the x. Some books write the x as capital letter, but it doesn't matter, right? So X can have capital letter, can have a small letter, but other than that, if you see any capital letter or if you see any Greek letter which does not belong to English A, B, C to Z, that formula belongs to the population, right? Okay, now we move on to the next average. What is the next average? The next average is called median. Median. So the median is easier to find than a average. Yeah, the mean. Why? Because you don't need to add any number. So what basically I show you with an example first. If you have 5 numbers, okay, so this is the 5 numbers you have. You arrange the 5 numbers and the 5 numbers shows 1, 2, 3, 4, 5. So which number is right in the middle? Number 3. So median is 3. If you have a number, 5 numbers, and the 5 numbers shows this 1, 2, 3, 4, and 10. So which number is in the middle? 3, still 3, right? So very stable, right? Median is very stable. If you imagine that you're going to find the mean for this, the mean for this will be 1 plus 2 plus 3 plus 4 plus 5 divided by 5, you will get a 3. What about this? What is the mean? 1 plus 2 plus 3 plus 4 plus 10. 4 and 3, 7, 10. So you get 20 divided by 5, so you get a 4. So you see that if you have a big values, somehow the mean becomes bigger, but the median stays. Yeah, so median is very stable. It will not be affected by extra values. That means big values or small values in the data set, right? Okay, so median is also can be explained as the number right in the middle, right? So if something right in the middle, that means half of the data will be below it, half will be below it, and half of the data will be above it. Okay, right. So how do we actually calculate median? Let me show you with two methods. Yeah, one method is no matter which method you use, you have to arrange it from the smallest first. So from the smallest number up to the biggest number. Okay, then the first method is you just cancel, right? So okay, you just say okay 1 2 3 4 5. Then you say 1 2 3 4, sorry, 1 2 3 4 5. Then you still have, right? So you say okay 1 1, then this is left over. So this is median, right? Show you another one. This is another example. Yeah, so you take 1 2 3, 1 2 3. Oops, you have 2. So if you cancel this, there's nothing in between, right? So the median is right in the middle of 2. So you just take the average of these two. Average. Yeah, you just take the average. Okay, now I go back. This is one way you find it, the easier way. Right. So there's another way where you need this formula to calculate for the another part. Okay. So that's why I need to explain to you. There's another way you can calculate it is using a formula. So the formula goes this way. Where's the formula? This is a formula. I equals to half n. So median is right in the middle, is half. So n is the number of data points you have. So we just need to put the n. So for example, you look at that. If you have half, okay, show you. If you have 5 numbers here, okay, so what is the n? If you have 5 numbers, n will be 5. Then according to this formula, the median index will be I. I is half n. So I is half n. So half n is how much? Half n is 5 over 2. Which is 2.5, right? Is it correct? We don't have a number which is in the middle of 2 and 3. Okay. 2.5, that means in the middle of 2 and 3. So it's not the right way. So there is a rule when you use this formula. Okay, so the rule is shown here. So when you use this formula, you end up I equals to not an integer. For example, just how we calculate that I ends up with 2.5. It's not a round number. Integer means round number. Then we are going to round up. Up, yeah? Up means you go to 3. Right, so if you look at that, then the median should be the third number. Okay, the median should be the third number. So what is the third number? The third number is this. But if the I ends up with a round number, yeah, so for example, you have, I just list down a few number, 1, 2, 3, 4, okay, these are my number. So if you use the I, you find that the I will be half n, and the n will be, there are 4 numbers here, so I put 4 here, and I get a 2. So I is 2. So can I say the median is 2? At one look, you know median cannot be 2. Median has to be here, right? So how should I handle that? According to this rule, it says if I start with a round number, then the median, you have to take this second number, then you have to add the next number. Okay, this is text second, this come from here. Second, then you have to add the next number, then you divide by 2. Okay, so you are taking the average of this value, the position I, which is 2, and I plus 1, which is 2 plus 1, which is a 3. So you take this and divide by 2, that will give you this, which is the value of the median is 2.5. Right, so here are some examples again. There are 13 numbers here, and if we use this formula, you get equals to half n, then you get 6.5. So according to what you have here, if you don't get the round number, you are not an integer, then you need to round up. So you round up to 7. So you just count which is the 7th number. This is the 7th position. So the median will be this, which is a 12. Right, so another one, you have 8 here. So half n will be half times n, and you get a 4. So according to this, just now we show that if you get a round number, an integer is round number, you just need to get the average of the I and the I plus 1, the next number. So you get 4. The 4th number is this. Okay, so you get the 4th and the 5th. The 4th number is 12. The 4th comes from here. The 4th number is 12. And the next number, which is the 5th number, which is 14. So you get the average of these two, and that will be the median. Okay, so of course you feel that the first method is easier, right? So it is okay if you use the first method to find out. Yeah, there's no indication. You won't be asked to do it in a formula way if the first method can use. Yeah. Okay, now what is the third center or the third average that statistics has? The third center is called mode. Mode is even easier to find out. You just need to find out which is the values in your data set that most frequent. Okay, which is the most frequent that it appears. All right, so let's look at some of this. If you look at data array 1, the first one, every number appear only once. So we say there is no mode for this data. For data array 2, find that there are two number 4. So number 4 is the mode. There's only one mode in this data set. We call that unimodal. Okay, and the third data set, you have 4, 4, and 9, 9. The rest only appear once. So 4 and 9 appear equal number of times. 4 appear twice, 9 also appear twice. So both of them are modes. So if you have two modes in English, you call that bimodal. So remember that the graph that you've seen earlier, if they have two peaks in the data set in the graph, then you call that bimodal. Okay, now how about those data already arranged in the table form, like what you have seen earlier, 10 to under 20, 20 to under 30, and so forth? How do I find mode? Because I lost the original number. I don't even know those numbers, 6 numbers under 20 but 20 but under 30, so 20 to 29 point something. I have totally no idea what is the actual value. So how do I find out? You don't need to find out. Okay, so when your things are already summarized in this table, what you need to find out is the model class. The model class means the class which has the highest frequency. Which class has the highest frequency? Second one, right? So this class is model class. Okay, right. So I just show you the original data down there, right? So if you look at the original data, 24 and 27 actually is modes of this original data. So when you put up into a frequency distribution, you lost the original number. But you can only the frequency is the highest frequency is 6. So the second class is the highest. Now, not necessary that the modes, the actual mode must fall inside the model class. It may not be always true. Okay. Right. So at this moment, you don't need to like memorize everything here. You just need to take note of a few things. Mean is sensitive to extreme values. If you have big values in your data set, your average, the mean will be bigger. Median, not sensitive to extreme values. Okay, so I think this is the most important that you need to know. And you just also need to know that mode sometimes is not so useful when it comes to number. Just now you also see that we can have an situation where we have no mode. How can you say that a set of data has no center? Mode is one of the center, right? So it's not appropriate to say that there's no center. There is a center, just that the center is not suitable to be represented by mode. You can use mean, you can use median, right? So in another word, mode is more useful for categories. Yeah, it's more useful for categories. Okay, okay, right? What's the best measure? So what's the best measure is, now you see that median is very stable. If you have big values or small values in your data set, seems that it will not be affected by that big or small values. It is very stable. So in other words, if your data has extreme values, which we have a technical word here called outliers, if your data have extreme values, then median will be used to be reported as the average. Okay, so if we want to report an average for that particular set of data, which has extreme values, which is called outliers, then median will be the better value to tell about the center, not the mean. Clear? Up to here? Okay, now later I'll actually explain this. Yeah, so at the moment, you can just take a short break first, then we come back here. Right.